I want to show you a neat way to figure out the derivative of arctangent of x. This is going to work whenever you know the derivative of a function and you'd like to know the derivative of the inverse function. And to start out, I'm going to choose the point xy equals 1 pi over 4. We know the arctangent of 1 equals pi over 4. So I'll show you how to find the derivative of arctangent at the point 1, and then we'll find the big general formula. So the way we're going to start this story is I want to look first at tangent. And I know that if y equals arctangent of x, then tangent of y equals x. Of course, tangent of pi over 4 equals 1. And so these are inverse functions. I mean, they're sort of inverse functions. The story behind that is that if you take a tangent and you look at the graph of that, you've got all these vertical asymptotes. But if you restrict just to the interval of negative pi over 2 to pi over 2, and then that portion of the function is invertible, you flip that over the line y equals x, you switch the x and the y coordinates, it's going to give you the graph of arctangent. That's why, strictly speaking, we call it arctangent instead of tangent inverse. And so what I'm going to do is I'm going to take first the derivative of tangent. And I want to take the derivative of tangent at the point pi over 4 so that I can then find the derivative of arctangent at the point 1. So tangent, take its derivative at any point, and you're going to get secant squared. And so when I plug in x equals pi over 4, and get secant squared pi over 4, I'll let you check that that's equal to 2. So that tells me that the slope of the tangent line to the tangent function is equal to 2, and it goes through the point pi over 4, 1. So I've got a point y x equals pi over 4, 1, and I've got a slope m equals to 2. And I'll now write out the formula for that tangent line. The formula you'd use is y equals slope times x minus your first coordinate plus your second coordinate. And there's the tangent line. And actually, I'll show you right there, there's a graph of tangent and its tangent line. And so if I want now the graph of arctangent and the tangent line to arctangent, what I can do is I can just flip all of that over the line y equals x. In other words, just switch the x and the y coordinates. So I'll go ahead and show you that. And you can see, whereas I started with a tangent line to tangent at the point pi over 4, the new line becomes the line tangent to arctangent at the point 1. X equals 1, y equals pi over 4. So now all I have to do to figure out that derivative is to figure out the slope of the reflected tangent line. And in order to do that, what you can do is this classic trick of switching x and y and then solving for y. Another thing you can do, if you already know what the answer is, the formula for doing this is the slope becomes the reciprocal. And instead of pi over 4, 1, we're now centered at the point 1 pi over 4. So you could do this either way. You could switch x and y and solve, or you could just go straight to writing down the answer, knowing that the equation for a line that's reflected over the line y equals x has that formula where you just switch the x and y values and divide by the slope. And so this tells you that the slope of this line had to be the derivative of arctangent at the point equals to 1. And so let's probe into that a little bit more. Because that number 1/2, it didn't just come out of nowhere, it was 1 over the derivative of tangent at the point pi over 4. And remember, 1 pi over 4, those were our x and y values. So if you do this whole process now and want to find the derivative of arctangent at the point x, or any point x, it's going to be 1 over the derivative of tangent at the point y. And this formula works for any function and inverse function. So you want to find the derivative of a function. What you do is just take 1 over the derivative of the inverse, except you plug in the point y instead of the point x, because they get switched when you take the inverse. And so now the question for us that we have to figure out is, how can we find a general formula for this, like in terms of x, the formula that we can actually use? And in order to do that, well, first I'll go ahead and take the derivative. I'll remember that this is 1 over secant squared of y. And this is the thing that I want to rewrite and find a formula in terms of x. And in order to do this, I like to go back to this technique that I call like drawing the picture of the equation. So our original equation was y equals arctangent of x, or tangent of y equals to x. And I want to draw a picture of that equation. And what I mean is I'm going to take a right triangle. I've got tangent of y equals x. So y is like my angle. So pick any angle other than the right angle and call it y. And you can choose any two sides of this triangle that you want, and then the third one will be determined. And so I'm going to choose the two sides in such a way to make it true that tangent of y equals x. And knowing that tangent is opposite over adjacent, I could just pick maybe x and 1 are the simplest things. And then by the Pythagorean theorem, that's going to tell me the square root of 1 plus x squared has to be the length of the hypotenuse. So now what I want to do is figure out what's the value of 1 over secant squared. Well, secant is 1 over cosine, so 1 over secant is just cosine. So really all I have to do is figure out what's the value of cosine of y, because I know that 1 over secant squared of y is nothing but cosine of y. So I figure out cosine of y and then square it, and then I'm finished. And in order to do that, well, cosine of y, I just have to remember that's going to be the length of the adjacent side over the length of the hypotenuse. So that's going to give me 1 over the square root of 1 plus x squared. And then, of course, I'm squaring it to get 1 over 1 plus x squared. And you put that all together, and that tells you that the derivative of arctangent of x has to be 1 over 1 plus x squared. So that's the classic formula. And you can use this, now knowing that you know the derivatives of the other 5 trig functions, you can use this to figure out the derivatives of all of the other inverse trig functions.